Suppose that f of x is 2x squared minus x plus 3, and g of x is 5 minus 2 times the difference of x and 3. Find an expression for f of x plus 3. Well, we're going to take function f, which is this fellow right here, and every place we see an x, we're going to replace it with an x plus 3. So we have 2, and then in parentheses, x plus 3, that's being squared, minus x plus 3 plus 3. For emphasis, I'm just highlighting where we replace the x with the sum of x and 3. When you substitute, use parentheses. This is a great example of this problem here, that if you don't use parentheses, your answer is going to be wildly wrong for a couple different reasons. X plus 3 squared is 2 binomials. We are multiplying x plus 3 times x plus 3. So we get x times x, which is x squared, x times 3, which is 3x, 3 times x, which is 3x, and 3 times 3, which is 9. If you combine the two middle terms, you end up with x squared plus 6x plus 9. That's a perfect square trinomial. If you distribute this minus, you're going to get minus x minus 3 plus 3. If I distribute the 2, multiplying every term in the parentheses by 2, these 3's cancel. And then my final answer is 2x squared plus 11x plus 18. And that is because this 12x and this minus x are like terms. Find an expression for this monstrosity. All right, well, let's try to do that. So we have f of x minus 2 minus g of 2x. That's going to equal. I'm going to take function f. Every time I get to an x, I'm just going to put parentheses. Tell you what, I'm running out of space. I'll put this down here. And for emphasis of where things are going, I'll do this. So what you see here on the left is f of x minus 2. We're subtracting from that g of x. So since we're subtracting, I'll tell you what I'll do to make this more obvious. I'm going to put brackets around function f of x. I'm going to put brackets around function g of x. Hopefully you'll see why here in a moment. Function g is 5 minus 2 times 2x minus 5. Nope, 2x minus 3. So let's discuss. I'm sorry, these are supposed to put an x minus 2's in here. I meant to do that when I got done writing the empty parentheses, and I didn't. Let's see if we wrote this correctly. F of x minus 2 means that we take this function f, so it's 2 times x minus 2 quantity squared, minus x minus 2 in parentheses plus 3. Got it. These brackets signify this is function f. Are they mathematically needed to do this problem correctly? No. We subtract from that function g. G is 5 minus 2 times x minus 3. So we have 5 minus 2 times 2x minus 3. Are these brackets mathematically needed to do this problem correctly? Yes, because of the subtraction in front of it. If we simplify this, we're going to get 2 times x squared minus 4x plus 4 minus x plus 2 plus 3. I'm going to hold off distributing this minus for now, so I'm going to leave this in brackets, minus brackets. If I distribute the 2, I'm going to get minus 4x minus 6. And I'm going to also, I didn't close my parentheses over here, I'm going to put this in blue. This x minus 2 times x minus 2 gets doubled because of this 2 out here, so I need to have parentheses to do that. I'm going to also leave this in brackets for now. If I then distribute the 2, I'm going to get 2x squared minus 8x plus 8 minus x. I can put this 2 and the 3 together and get plus 5. I could distribute this minus now and get minus 5 plus 4x plus 6. Now if I combine like terms, there's only one term that has an x squared in it. It's the first one, so that's cool. Minus 8x minus 1x, that's minus 9x, plus 4x is going to be a minus 5x. Constants, minus 5 and a plus 5 cancel. I have a plus 8 and a plus 6, which is a plus 14. That makes me a little bit nervous because on my key, that's not what I have. Let me just check this out real quick to see. Oh, I did make a mistake. Right here, when I distribute this negative 2 times 2x is a negative 4x. Negative 2 times a negative 3 is a positive 6. When I then subtract and distribute this minus 5 minus 4x should be a minus 6. Which means when I combine 8 and negative 6, I get positive 2. Because this plus 5 and minus 5 still cancel. All kinds of room for error there. Now, one thing that would have made this easier for us, a lot easier, is to simplify this at the very beginning. I intentionally didn't do that just to show you the mess that can create. We could change this to 5 minus 2x plus 6, which in turn could get changed to negative 2x plus 11. Had we done that at the very beginning, it would have made this a little bit less complicated. In fact, I'm going to do that for this next part. We are supposed to make an expression for this monster. Now this is a very important thing in calculus. We will get to this at some point. It is called the difference quotient. It is the difference quotient. It's a fancy way of writing slope, if you can believe it. All right, so we are supposed to take in our numerator function g, which I've just written like this now, replacing all the x's with x plus h. Then subtract from that function g in its original form. So we got negative 2 times x plus h plus 11. We're subtracting from that the original g of x, which is negative 2x plus 11. When I say original, I am using the simplified version, which is negative 2x plus 11. It's going to make everything simpler if I do that. This is all over h. Once again, this is g plus x plus h, which is what this is. This is just g of x. This whole thing's over h. If I simplify this by distributing the negative 2, I'm going to get negative 2x minus 2h plus 11. If I distribute this minus, I'm going to get plus 2x minus 11. If I combine like terms, a minus 2x and a plus 2x cancel. Plus 11 and a minus 11 cancel. We're left with negative 2h over h. We can factor an h out and cancel it. We're left with negative 2. Find an expression for f of x plus h minus f of x over h. This is also the difference quotient, a fancy way of writing slope. It's the same as this, but instead of g's, we have f's. So we're going to have f of x plus h minus f of x all over h. F of x, which goes here, that's the easiest. I'll write that down first. That's 2x squared minus x plus 3. Here, I'm going to write down function f. But every place I see an x, I'm going to replace it with an x plus h. Now we need to get rid of our parentheses, not blanketly, but by doing the operations. So we're going to square x plus h, and that's going to get multiplied by 2. We're going to distribute this negative in here. It's going to be negative x minus h, bring down the plus 3. Let's get back to this, which I kind of skipped. If you multiply this by itself, you will always end up, and you don't have to take this shortcut, you can multiply it out on the side here, and end up with the first term squared. You're going to have the last term squared, and the middle term is going to be this product doubled, which is going to be 2xh, or 2hx. If you multiply a binomial times itself, it always fits this pattern. First term squared plus, or it could be minus if this was minus here, the product of 2 and the first term and the last term, and then plus the last term squared. This here was distributing the minus, bring down the plus 3. Going to distribute this minus now and get minus 2x squared plus x minus 3. This is all over h. Getting closer, let's distribute these 2's, or this 2 I should say. Get 2x squared plus 4hx plus 2h squared minus x minus h plus 3 minus 2x squared plus x minus 3. And now we let the bloodbath begin. We got a 2x squared, we got a minus 2x squared. We got a minus x, we got a plus x. We got a plus 3, we got a minus 3. What are we left with? We are left with 4hx plus 2h squared minus h over h. You can factor an h out of the numerator. It's GCF. Whoops. You can cancel an h from the top and the bottom, which is going to leave us with 4x plus 2h minus 1. All that work, and we get down to that little fella right there. Let's see, we got another half page here. Should take more than 4 or 5 more hours, and we'll be finished. Find an equation for g of h of x. Now, we've already kind of done this. I'm going to skip. I'm not going to skip it. I won't take the easy way out. G of h of x. So we got function g. Maybe we actually haven't done this. We're going to put function h in for it. So that means that we're going to take function g, which is 1 minus 2 times x. We're going to replace the x with 3 over 2x minus 2. We distribute the 2. We're going to get 1 minus 3x minus 4. Combine like terms. I'm sorry, that will be a plus 4. A minus 2 times a negative 2 is a plus 4. That would give us 5 minus 3x. Find an equation for g of f of x. So take function g and replace f with a negative x squared plus 3x minus 5. Function g is 1 minus 2. We're putting in for the x that's in that, negative x squared plus 3x minus 5. We distribute the negative 2. Combine like terms and put this in descending order with respect to the exponents. We get 2x squared minus 6x plus 11. C, senor. F of g of x. We're going to take function f, and we're going to replace all the x's with g of x, which is 1 minus 2x. Function f is negative x squared plus 3 times x minus 5. Just for emphasis, this highlighted things were x's originally, and we replace them with 1 minus 2x. 1 minus 2x squared is going to be 1 squared, which is 1, minus 2x times 1 doubled, which would be a minus 4x, and then plus this squared, which would be 4x squared. It's in parentheses because I have this negative out here, which I have not used yet. If we then distribute the 3, we're going to get plus 3 minus 6x, bring down to minus 5. If I now distribute this negative, I'm going to get negative 1 plus 4x minus 4x squared. Bring down the plus 3, the minus 6x, and the minus 5. Minus 4x squared has no like term. Plus 4x and a minus 6x gives us a negative 2x, or subtract 2x. And then a minus 1 and a plus 3 and a minus 5, that's going to be a minus 3. Alrighty, D, P of g of x. So in function P, we're going to replace all the x's with g of x, 1 minus 2x. Function P is x plus 2 over x minus 3. Our x's are 1 minus 2x. Combine like terms in the numerator, you get negative 2x plus 3. In the denominator, you're going to get negative 2x minus 2. Done. Ichiro. Find an equation for this. Really, it means an expression. So we have negative 6x times h of x. H of x was 3 over 2x minus 2. Subtracting that function f. Function f was negative x squared plus 3x minus 5. If we distribute this, negative 6 times 3 halves. Let's see, we can divide negative 6 by 2 and get negative 3. It's going to be negative 9. X times x is x squared. Negative 6x times a subtract 2 is going to be a plus 12x. Distributing this minus, we're going to get a plus x squared minus 3x and a plus 5. You combine like terms, we're going to get negative 12x squared plus 9x plus 5. That's incorrect. Negative 9x squared and a plus 1x, that's an 8x squared negative. Yeah, negative 8x squared plus 9x plus 5. E, F, G, let's do G, and then we'll do F. Find an equation for f times g of x. Well, that's the same as f of x times g of x. Multiplying two functions. Function f is negative x squared plus 3x minus 5. Function g is 1 minus 2x. So I'm going to multiply negative x squared times both of those terms and get negative x squared plus 2x cubed. I'm going to multiply 3x times each of these terms and get plus 3x minus 6x squared. And multiply -5 times each of these terms, you get -5 plus 10x. If I then combine the like terms, see, I got a -x squared and a -6x squared, a plus 10x and a plus 3x. So I'm going to have a 2x cubed minus 7x squared plus 13x minus 5. Yay! F, for what values of x is f of x equal to g of x? Well, f of x is negative x squared plus 3x minus 5. G of x is 1 minus 2x. I have to get all the terms on the same side, and I'd rather have my x term, its coefficient, to be positive. I'm going to move everything to the right. If I subtract a 3x from both sides, a minus 3x and a minus 2x is a minus 5x. If I add 5 to both sides, a 1 plus 5 is 6. This is a trinomial. Lead coefficient's 1, so we can go directly into binomials. Two things that multiply to get positive 6, add to get negative 5. That would be like a minus 2 and a minus 3. Set each factor equal to 0 and solve each of those little fellas. And we get x could be 2 or x could be 3. Last one. Find an equation for g plus p of x. Well, that's going to be the same as g of x plus p of x. G of x is 1 minus 2x. P of x is x plus 2 over x minus 3. Now you might be wondering, why didn't I use parentheses? Well, you said when you substitute, use parentheses. Well, parentheses is really a poor choice of words. The better choice of words is use grouping symbols. A fraction is a grouping symbol. This is all one group. So if you want to put parentheses here, you can. It's not needed because this is already assumed to be one group. To add these together, we're going to have to get common denominators. To do that, the denominator here on this first term is just a 1. So I'm going to have to multiply this first term by 1, because if you multiply by 1, it doesn't change its value, in the form of x minus 3 over x minus 3. By doing that, I'm going to have common denominators here. So my numerator, if I multiply this stuff together, I'm going to get 1 times x is x, 1 times minus 3 is a minus 3. Negative 2x times x is negative 2x squared. Negative 2x times a minus 3 is a plus 6x. Since we have common denominators, we can put these fellas together. Make sure I multiplied this stuff out right. I think so. So we add these together, we can make it as one fraction. We have some like terms here. We have an x plus a 6x plus an x. That's an 8x. We have a minus 3 and a plus 2. That's a minus 1. And we have a minus 2x squared. That's different than what I had on my paper, on my notes. Let me just check to make sure that I did that correctly. Yeah, I believe so. If I didn't, I apologize. That concludes the notes. That took forever. That's probably a 2-dayer in class. So please do the homework from 1.6.